to our presentation. Today we'll be learning about the wonderful world of mathematics that lies all around us, the physics that help us operate in our day-to-day life, and also about the engineering that goes into the architecture. Hi, welcome to Mathematics with Mr. Mills. Today we'll be studying parallel lines. So, parallel lines, they have the same gradient. They have so much in common, it's such a shame that they'll never meet. To Math with Mr. Mills. Today we will be studying the Pascal's triangle. Okay, so Pascal's triangle is basically a triangle where all the sides are made up of ones, and then each number is the sum of the two numbers above it. So if you do this, you get the coefficients of polynomials. So 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, etc. Hi, welcome to Mathematics with Mr. Mills. Today we'll be learning about sound waves. So on a large instrument, such as this drum, when you hit it, it makes a really low pitch, whereas on a smaller instrument, it makes a really high pitch. So, to explain this difference, as you can see, on a big instrument you have a very low frequency, whereas on a smaller instrument you have a very high frequency. And as you might remember from your IGCSE physics lessons, the frequency of a sound wave determines its pitch. Now, today we'll be learning about absolute functions. So this is a graph of y equals absolute 2x. So on the negative side, so for example, if x is equal to -2, then y will be equal to 4. This is because on an absolute function, negative numbers are turned into positive. So when we graph it, it never goes into the negative axis. Instead, it reflects right back up, which is why we have this shape. Hello, this is the y floor of x function. So let me explain it. This is the origin. So basically, if you have y equals x, you have the classic ascending function. But if it's the floor of x, then it rounds every number to the lowest number. So here, 0 to 1 would all be 0. But as soon as it goes up to 1, it goes up. And then 1, 1.5, 1.8, 1.9 is all rounded down to 1. So it all stays at this constant value. So instead of having the classic, going up sort of gradient, we have a zigzag shape because this is the nature of the function. Oh, hello, welcome back to math class. So, you are probably wondering, what shape is this swing? It is a parabola. So this is the origin, this is the graph. As you can see, it's quite narrow, unlike that over there, if you remember, the big frame. Okay, so this suggests that a in y equals ax squared plus bx plus c must be larger than y. Okay, something else you might notice. As you pull away, it becomes narrower. As you go in front, it becomes wider, yes. So, let me demonstrate this for those visual learners out there. Wider, narrower, wider, narrower, wider, narrower. And back to classic parabola. So, ignoring friction, which is a bit hard right now, there's a wasp! Okay, you'll realise that if this is the angle, theta, I was accelerating down this inclined surface at g sine theta. Welcome to our presentation. Today we'll be learning about the wonderful world of mathematics that lies all around us, the physics that help us operate in our day-to-day life, and also about the engineering that goes into the architecture. Today we will be learning about the circle. So, the circle is when you graph x squared equals y. The teacher's judging me,